All right, so we are back, Channel 9 Live, TechEd Europe 2012, and we're going Roslyn, Project Roslyn, which is compiler as a service. We have Dustin Campbell here.
Hey.
How you doing?
I'm doing all right.
And people can see his great talk from Lang.next that just happened this year.
Yep.
He presents that. And of course, you're talking about that here, this event.
I'm not doing a Roslyn talk.
Oh, you're doing. What are you doing?
Well, when we send people off to TechEd Europe, I have to do an F# talk, C# VB async talk, and just a general Visual Studio tips and tricks talk.
So we're going to save the real interesting stuff for this panel.
That's exactly
then,
right.
So let's for people who don't know, I mean, compiler as a service. Explain.
Okay, so actually, I'll start by just saying, we started calling this compiler as a service a number of years ago.
Yeah.
And it's been kind of a confusing name, especially as a service has started to mean more about cloud development and applications in the cloud. And so I've even seen blog posts that say, hey, when Roslyn comes along, they'll be compiling our code in the cloud. And that's actually not what Roslyn is. The as a service part, what we really mean here is exposing APIs from the compiler that you can use in your own applications or your own tools, whatever you want to use, something that gives you semantic information about source code, you can use as a service, so to speak. Sure. So at its heart, Roslyn is rebuilding the C# and Visual Basic compilers in C# and Visual Basic. Today they're written in C++.
Yeah.
And so this is kind of the first important milestone for some compilers is to get implemented in their own language, and we're finally 10 years down the road for C#. We're going to hit that milestone. Yeah. Now that's important, but as we go ahead and we do all of that re-implementation, we're really taking it slowly, and we are building this public API on top of it, because the compilers, they have all this information about source code. And I mean, I know there's a lot of people out there that have written tools where they just maybe they just want to highlight some code and colorize it in HTML. And for that, you have to go and write your own C# parser, which just seems like a lot of overhead, right?
Sure.
And so Roslyn gives you those APIs to that information in the compiler, all the semantic analysis, to be able to build those tools. Now Roslyn's really big. On top of that, we're building higher level APIs to do things like, say, given a symbol from some source code, find all the references to that. So even some things that might be part of IDE functionality, we're building as APIs that you could use in your own applications. On top of that, we're also rebuilding the C# and Visual Basic editing experiences, the actual IDE language services on top of the public API surface.
Nice.
That helps us, prove out those APIs, make sure that they're powerful enough to drive something like IntelliSense.
Yep.
And then on top, and that's kind of the core, the heart and soul of Roslyn is all the way up. We're building this semantic analysis, editing experience, really the entire language stack. So it's kind of a big project. One other piece of it, it's just another API. It's kind of on the side, but it doesn't really fit in that stack, but it's an important part, is our scripting APIs.
Okay.
And so those allow you to dynamically compile C# or Visual Basic code. Use it in your application. You could dynamically compile, say, maybe your application has a text box where a user could write a macro, and you could dynamically compile that, attach it to a button-click event handler, and now your application is scriptable. So there's a lot of pieces of Roslyn. It's a very, very big project.
Now, on the latter piece, we've had that in .NET for a while.
Sure, we've had
that
pieces
was called, what was that called? You could compile code inside of an app.
Sure, you could compile code. You could use things like code DOM and that sort of thing.
This makes it much more natural.
This is the real compiler, really, and literally you pass it a string. It can be whatever you want. There's no restriction on the sort of language features you can use that you have in code DOM. It's just beautiful.
That's excellent.
Yeah.
Now, I mean, we have a question coming. Please ask questions at #CH9 Live. Roslyn, or I guess they could ask you other questions as well, but let's try to keep it focused.
That's fine.
To Roslyn. This is a C# VB guy.
Yep.
Won't there be a performance hit if the Roslyn compiler is built in C# and VB? I mean, that's a fair question.
So that is a fair question, and the answer is yes. There will be a performance hit in the sense that if I were to do a command line build of just CPU-bound compilation, yes, the native code is definitely going to be faster than code that has a JIT and has a GC. That's reality.
Yeah.
But what Roslyn gives us is the ability to kind of take advantage of some things we've never had before. With a native compiler, it's very hard to do something like say if we wanted to bind all of the method bodies in parallel. That would be very difficult to introduce into the existing compiler. Or if we wanted to maybe MS Build could start up with the entire framework already loaded so that every compilation doesn't have to take the hit of reloading all
Absolutely.
that metadata every time. So it opens up some new scenarios for us to kind of mitigate that. So our expectation is that, yeah, on a single core machine, Roslyn compiler will probably be a little bit slower. Right now, I think, I read some numbers, I thought we were like around 1.4 times the native compiler, something like that. But as you start adding cores to your machine, we hope and we are trying to make Roslyn to actually perform better than the native compiler in that scenario.
That kind of leads to a question. In the C++ world, you have the front end compiler, which is what you deal with the syntax and semantics of the language. You plug that into an IDE, blah blah blah. Then you have the back end compiler that actually does the hardcore optimizations, removing unnecessary loops and functions that don't get called, and spits out machine code. So one question would be, was there any thought when you were doing this project of refactoring the C# and VB compilers into two compilers? So you'd have the front end where Roslyn could live.
Sure.
And then you'd have the back end that would just produce highly optimized code. But of course, you guys do IL.
Sure.
So
when you do IL, like the C# compiler today doesn't actually do all that much optimization. It's certainly not as I guess as rigorous as the C++ compiler is, right? Because it relies on the JIT compiler, and the JIT compiler's optimization is if we start optimizing, then the JIT compiler might not be able to do its work.
Understood.
And so often with the C# compiler, there's less optimization. We do have a goal of sharing some code, quite a bit of code between the compilers. So some of those pieces like that go through and do some of those optimization passes, those are actually shared between the C# and VB compilers and Roslyn. So there's essentially every layer of Roslyn has 3 assemblies, one for C#, one for VB, and then one that's common in the middle where they share kind of common functionality.
Excellent. So it sounds like right off the bat that Roslyn is going to be a great tool and a great set of APIs for, Visual Studio vendors who had to struggle with, maybe not struggle, but it'll be a lot easier for them to build some powerful tools.
Yes, absolutely. And as part of the rebuilding of the language services, we're offering extensibility points that have never been there before either. So a key goal of Roslyn is to really provide that insanely great IDE that we want to provide. So Roslyn at the IDE side, which is where I primarily work, is all about refactorings and quick fixes and doing a whole bunch of work there that really C# hasn't done since 2005, and Visual Basic has never done. So actually bringing that out for the very first time in the product and really taking a strong run at it and providing extensibility so we can build an ecosystem about that. So Charles, you could go and write a refactoring for your own thing using the Roslyn APIs and plug it right into Visual Studio.
Awesome.
Yeah.
Awesome. All right, we got questions here.
Yeah.
So Al is asking, do you think Roslyn will replace the native compiler in the long term?
I think, yes, it will replace the native compiler in the long term. In the short term, that's not something we take lightly. People have asked me, the performance question always comes up, and I usually say that's not the main challenge of Roslyn. The biggest challenge is duplicating and making sure that we work with all the legacy code out there, because there are, as hard as we try, there are bugs in the C# compiler that we either know about or we don't know about that people have taken dependencies on their code. And we need to make sure that we don't break that. So it's not clear what the release will look like. I think in the short term there could be a side-by-side release, but in the long term the goal is this is the C# compiler moving forward.
Sure.
And new language features will be added here and not to the native compiler. So it's possible that the native compiler will live for those legacy applications to make sure that nobody runs into kind of those bugs and that sort of thing. But that's generally the plan right now.
No, and I mean, I think, and as you said, you sort of said in your introduction, it's in the art of designing and implementing programming languages, one of the exercises you always do is build your compiler in the language you're compiling.
It's a great unit test, right?
It's the best. It's the best there is.
Yeah.
So it's great that you guys are finally doing that.
Yeah.
And I mean, C++'s compiler is written in C and C++.
Yeah.
F#'s compiler is written in F#.
Yep.
Et cetera, et cetera. So we have another question here from Hood. Will part of Roslyn be usable in Metro-style app, like a code highlighter for some bug tracking client in Metro?
So the answer, I believe, and I haven't tried this yet, so caveat that. The answer is yes. There are pieces of the scripting API that won't be available in a Metro app. They use reflection emit, and that simply just won't be available. But the pieces that analyze source code and do all that work, I can't see a reason why they wouldn't be available for Metro, other than the fact that I haven't tried it yet.
Yes.
So caveat that there is a CTP out there. You can try it.
Yep.
There's a NuGet extension that you can just grab the Roslyn compilers and give it a shot. So, yeah.
So, of course, Al likes asking questions that we're not going to answer, but I don't think Roslyn for C++ is crazy at all. Were you saying C++ wax CLR?
I think it means CLI.
Yeah, and you don't really need Roslyn for F# because you can
download the F# compiler source.
Yeah, exactly.
From CodePlex.
But those are good questions. It's not crazy, Al.
It's not crazy.
I mean, I think Roslyn for C++ would be great. It's a little bit more of a challenge, a different sort of challenge.
It's a different sort of challenge, and I know there's some people on the C++ team that have been thinking about that and looking at that. For Visual Studio 2012, they've definitely got some big focuses. I mean, they've done a lot of ALM work, a lot of IDE work, and especially their partnership with Windows, right?
Sure.
So this hasn't been kind of their chief focus.
Sure.
But that would be that, they would need to go and do the investigation and decide they want to do that and they want to make it a priority.
Yeah.
I think it would be absolutely great, but for us, for the Roslyn team, we decided, for this release, we need to put the blinders on. It's C# and VB because we need to get done.
Yes.
As I understand it, now I've only been at Microsoft for 4 years or so, but when I joined Microsoft, this project was already happening, and it was happening in a different form, and I hear that it was happening in a different form before that, and a different form before that. And so this time, we put the blinders on, and we were going to focus, and we were going to get this done, and get it out there so that people can use it and get the value.
Awesome. Now let's talk about people using it, getting the value.
Yeah.
Roslyn has been available in CTP form for some amount of time.
Sure.
How are you seeing people in the real world use it? Are there any surprises? Because not everybody's just going to build design time tooling like
right. No,
experience.
of course. So to be honest, there's been less actual people trying to use it because we are in active design and things are changing.
Sure.
There have been some interesting ones. You asked for a surprise. I was talking to a friend, an MVP, that was saying, "Hey, we're going to use it at my company as soon as you can give me, deployment licensing for it, which is in the CTP. You can deploy some of the Roslyn assemblies and use it." But he was going to use it to dynamically compile business rules within his database, so that he could get his data out with the rules already transforming the data properly for him. I was like, well, I had not expected that. That's a great idea.
Awesome.
But really, the sky's the limit for things that you want to do that are about source code. And there's a couple of MVPs out there that are playing around with trying to do some aspect-oriented programming kinds of approaches with Roslyn. I mean, that's not exactly a design goal of Roslyn. It's not something we have built in, but they're going out there and they're doing work and they're hacking it out and see what they can get done. And it's pretty cool, some of the stuff that has been put out.
So one question I would have, would it be possible with something like Roslyn for you to, I'm not going to say extend the language, but to add in your application source code or somehow use Roslyn to extend the language?
I'm not going to say extend the language, but extend the language.
That's what I'm saying.
That's right.
Because it is a compiler API, but I understand there's going to be a difference, but I need to hear the answer.
Right. So
to understand.
No, the goal is not to allow you to extend the language, at least from the syntactic point of view, right? I mean, we're not going to let you add keywords to the C# language, mostly because we want to continue to rev C# and we don't want to break everybody.
Of course.
Now, the ability to do things that people do today, like with something like PostSharp, where you add attributes and contracts and that sort of thing.
Yes.
Absolutely, and you can certainly do that sort of thing with Roslyn. You could hook into the MS Build pipeline, transform the trees as you want to do it, and looking at those attributes and do that work. Absolutely.
Cool, man. So I could have sort of a Eiffel-like C# if I wanted.
You could try something like that. Yeah.
Right on. I mean, the sky's the limit. I think that's one of the great things. So remember to tweet questions to whoa #CH9 Live. We're in Amsterdam. We're talking about Roslyn, which we're no longer going to call compiler as a service today.
That's fine.
Today, because I get where it's confusing. It's a compiler API.
Yep.
And it gives developers the ability to hook into the same infrastructure and at the ABI level, whatever, and ABI. So, because I'm thinking WinRT stuff like that. So the moral of the story is, it's a compiler as a service. It's an API. I do want to kind of go down the rabbit hole a little bit and follow the rabbit in terms of compiling in the cloud. Now, we do compile in the cloud for the phone apps that was announced recently. And that really is JIT in the sky, right? Cloud JIT
in the sky. I like that idea.
Yeah.
And
so there could be an interesting use where you did have this compiler infrastructure up there, and it's a legitimate service. You ship up code, and you tell it, I don't know what you would tell it. Now I'm getting down the rabbit hole now, but could that be useful?
That could be useful. I mean, and you could certainly use Roslyn to do that sort of thing, right?
Yeah.
Roslyn is, I mean, the way I look at it, it's a foundational component that, you know, we're working with partners inside of Microsoft to go do crazy and cool things with, right?
Awesome.
And so, you know, that's not something my team would go do, but we'd certainly say, oh yeah, here's Roslyn, go do that. If that's a goal, if that's a scenario we want to go after for customers.
Excellent.
Yeah.
So technically speaking, what's it been like from a technical challenge? Like you guys had to do a lot of, you know, you mentioned the term refactoring.
Yep.
You're refactoring the compilers, their architecture, and what's been some challenging work for you?
I would say from a design perspective, the biggest challenge is that in stakes in the ground we put about the architecture is that we want it to be immutable. So everything is a persistent data structure in the compiler, logically immutable, if you will. So when I get back a parse tree, it can't change. When I make changes to it, I get back a new one. I know you're totally familiar with all these functional ideas, but from the bottom all the way to the top, the entire Roslyn architecture is that way. So we actually have a persistent view of the entire solution, the entire type universe, everything is one persistent data structure. So when you build a refactoring, for example, you fork that universe and say, here's my transformation in that, and then we show a smart tag that says, here's all the available refactorings to you, each of those has its own potential possible future. It's like Doctor Who comes in and says, you pick it and say, oh, here, this is the universe I want to go to.
Awesome.
And so from a design perspective, doing that within kind of the CLR's framework and the GC, that's actually been pretty challenging for us. And creating an API that makes sense to people, teaching them about immutable programming, teaching them that when you make a change to a tree, it's kind of like doing string.replace. You get back a new string. That's been particularly challenging.
Sure.
Getting the raw performance, getting the memory usage. That's been some very clever use of structs around and that sort of thing, value types. And those have been challenges as well. But I think we're getting through that, and we've gotten through it pretty far. And today the compilers compile themselves, and all the unit tests pass when they do.
Right
so
on.
That's great. Yeah.
Right on. And they compile relatively fast.
Reasonably fast. Yes.
Excellent.
Yes.
Man. All right, Al is back with us again. Can you use Roslyn for decompilation as well, taking an assembly, making it an object tree, and outputting code?
The answer to that, Al, is no. Roslyn is not a decompiler at this point, and it doesn't show a view over IL. So Roslyn deals primarily with source code, and then you emit to IL, and at that point, the compiler is done. And so that's not something we're doing. And if we would do it, it wouldn't be in the first version, but it's not something we're looking at right now.
I mean, but theoretically, though, you could work at the IL level.
Theoretically, you can always work at the IL level.
Yeah.
You can still work at the IL level today. You can use CCI or other tools to do that. But
good question,
not part
Al.
of Roslyn.
Keep them coming, man.
Yeah.
So the Roslyn, let's take us through a little bit of history of, I know you started 4 years into the project, but take us back. I mean, why are we doing this?
Why are we doing this? So part of this is about the fact that there's a couple of reasons we want to do this. First, there's some internal efficiencies. It's really hard for us today. It takes a lot of time and a lot of resources to add new features, either to the compiler and to the editor. I mean, it's a 2-year cycle for Visual Studio, and you see how much we get into it every year. And so there's definitely some internal efficiencies that we want to address. We want to make sure that it's easy for us to add features. There are ecosystem reasons that we want to do this, and then also just because there are so many kind of half-baked APIs for doing what Roslyn does. I mean, we've kept the compiler a black box, and then we've allowed other people to kind of come in and put some other APIs in there, and it's just not really working out. We want to provide high-fidelity language APIs so that people can really build really smart, really cool tools.
Cool.
So, it's been a goal, I guess, for to hear Anders say it, he said this has been going on for 10 years in different versions of the project. And when I started, it was going on in yet another version of the project. And we said, you know what, we're going to reboot. We're going to take a different approach. The approach we were taking back then was we were actually going to start porting the native compiler to managed code and try and refactor after we'd done that. And that was not going great. That wasn't going very well.
That's a hard one.
That's a really hard thing to do, and it's actually in a lot of ways more time intensive. But that was the way that was thought of as the least risky in terms of legacy code and bugs in the compiler that we don't know about and that sort of thing. To keep those. But when we rebooted, we said, you know what, we're just going to start from scratch. We're going to use this as the original as our reference, and we're going to re-implement and re-architect from the ground up.
Excellent.
And that's at this point, Roslyn is, this one is going to finish. I can say that pretty certainly that this one will finish. I can't tell you which version of Visual Studio it'll be in,
doesn't matter.
Other than it's not in the current upcoming release.
It's not going to ship in
2012. Yeah.
So when you were designing Roslyn with the new architecture and starting from scratch, you mentioned sort of in some sense, at least what I heard was that it's composable.
Yes.
You built it such that, like function composition in that sense,
in a lot of ways,
compositional way, that you built it in kind of a modular way even, in that you can update a segment of it to add new keywords to some future version, but not break the rest of the compiler API chain.
Yes, in a lot of ways. I mean, you can add keywords to parse things syntactically and still not be able to actually bind them to types and all that. We broke the compiler pipeline into its major chunks, right? There's the parsing piece.
Yep.
There's the symbol table and the metadata import and the binder, which is most of the real guts of the real language. It's where overload resolution and all that stuff happens.
Okay.
And then emit, which is really small. Once we build up the binding, the end result of the binding, the abstract syntax tree or the bound tree, the emit's very small. It just literally just dumps that to IL. We had to build it a component at a time, right? So we started out by parsing the entire language, and we were able to parse everything. And so then the IDE would come in and say, well, we can build some features that are syntactic only. Like we built colorization, but it was only syntax. We didn't color types or any of that. We came in and we said we could do the outlining, the code folding. So building it a piece at a time. And then we came into the symbol table and designed that, and then we came in and started connecting the two together with the binder. That was over the course of about a year, I think, before we had the whole compiler pipeline built out and we got to Hello World. But we did build it a piece at a time, and it is sort of a transformation thing. There is a syntax API where you can do syntactic information. There is a symbol API that shows all the symbols in the type universe, either from metadata or from source. Then there is a binding API that you can use to ask questions about expressions in trees and bind those to symbols in the symbol tables.
Nice.
But yes, it definitely does kind of have this pipeline sort of feel.
Good.
There's a set of APIs around each one of those. And if we went today and we wanted to add a language feature syntactically at the front with a parser, we could do that without, and do it piecemeal at a time without breaking everything. So, I think that's the answer to your question is kind of yes.
Excellent.
Yeah.
Now, one of the things that I'm curious about in terms of, so you're going to take a performance hit because you have, essentially it's managed code, you have more in-memory processing and management. And
that's just the reality.
It's the reality of the situation.
Yeah.
However, one thing you could do, and I don't know, my question is going to be this. Are you working on multi-core strategies for the compiler?
Absolutely. I think I mentioned this earlier that essentially the plan of record is that on a single core machine we're probably going to be slower than the native compiler, but as you add cores, we want to take advantage of that in the compiler.
Great.
Every API takes a cancellation token. It's designed to be run on tasks or run in some asynchronous manner. And the IDE itself is also completely asynchronous. We've built it. We use the APIs asynchronously. We want to be able to do parallelism in the compiler. That would be that would be great. So that, because there's a lot of things that they don't need to happen in sequence. I mean, if I'm building all the method bodies of various classes, I can do that in parallel. I don't need to do that, wait for this class to be done, and then wait for this class to be done. And then also the idea that because it's immutable, because it's a persistent data structure. So for example, if I have there's a type called a compilation, and that contains trees and references. That's an immutable object. So when I add a new tree, I get back a new compilation. So we could start with an initial compilation with all of the references of the framework. everything in there. And then we could just add our trees, take no hit for metadata import, and just compile.
Wow.
Right? And save a good chunk of time with that.
Oh,
so there
absolutely.
are things we can do, both because of the immutability of the system, and also just because we can take care of advantage of parallelism that would be really difficult to do in the native compiler today, the way it's architected.
Sure. And the way it's architected, which is old.
Yes, which is
I mean, I would
ancient.
imagine the old compiler was C with some classes.
Yes.
I mean, you weren't using, you
Yep.
weren't using C++.
Right.
And a lot of times people say it's C++, when in fact, no, it's C, and you got a couple classes. You're not using any modern concepts. You're not using interfaces.
Yep.
You're not using blah, blah, blah. So what's the biggest problem you're working on right now?
The biggest problem we're working on right now. I think the biggest problem we've been working on recently is getting to a dog foodable state. So we, on the IDE, now the compiler's got its own performance quirks and that sort of thing, but it's really like an in and out situation.
Sure.
But when you're in the IDE, it's got to be tuned so that when I hit dot, it's fast. And we
Yes.
need it to be fast and responsive. And so, so recently for us, the big challenge has been getting the IDE to a dog foodable state. And we're trying. It's going to be a process, but it's going to be a painful process, right? You start using it instead of the default experience, and it becomes painful. But that's where we're at right now.
But the moral of the story is it gives developers themselves the ability to write, refactoring tools
Yep.
without having to there are some amazing refactoring tools out there. But I might just want to, like you said, have simple refactoring in this set of projects for myself. I write this much code.
Yep.
I mean, that will be really, really cool.
Yeah, another piece of that is that I used to work at one of these companies on a refactoring tool, and it was, we were addicted to using our own tool. I mean, we dog fooded and we were just addicted to it. I want to be addicted to using Roslyn, so
Cool.
That's where we're trying to get to.
Great. So we're trying to create Roslyn addicts, which is not a bad thing. It's a
Right.
good kind of addict. So, pound CH9 Live, ask questions. People in New York have got to be awake by now. All the developers in Amsterdam are here. Actually, that's not true. I know some I met last night that aren't here. But ask questions about Roslyn and C#. So other areas that you're working on besides Roslyn, obviously it's a full-time job.
Sure, Roslyn is a full-time job. It's absolutely a full-time job. I'm thinking about, I'm also invested in Visual Studio 2012 and helping out there.
Sure.
I'm thinking about Roslyn futures,
out there.
right, and all of that. So when I started, I actually, for Visual Studio 2010, I delivered the Visual Basic IDE as part of Visual Studio 2010.
Cool.
So I still keep a foot in what's going on right now and making sure that, things are going well and that we're going to ship that thing really well as well.
So one of the questions I would ask is, since you developed the VB compiler in VB.NET.
No, we developed it in, you mean for Roslyn, sorry.
For Roslyn,
yeah, sorry.
So the plan is
Yeah.
the VB.NET compiler in VB.
Yep.
I guess we just call it VB now, right?
I think that's
Okay,
it, yeah.
VB.
Yeah.
So the VB compiler now in VB,
Yeah.
the C# compiler now in C#. The VB has certain dynamic features that are different than. So take me through, did you have an easier time doing it in VB than C#? Which one, just out of curiosity, was harder? Is it essentially the same?
To implement as a language?
Yeah.
VB is far harder.
Far harder.
VB is okay, you asked about challenges. One of the things we kind of learned as we started this project, because there's not very many people around that have been on the VB compiler back when it was first written.
Okay.
And so there have been people that have been on it for a few years, but not a lot of people here from the beginning of that compiler. And VB, as it develops as a language, they try and add as much value as they can. And so there's a very magical sorts of value in the VB language, right? And it winds up that makes it a far more complicated language to implement. There are little features here and there on almost every language feature that just make it much more difficult to implement in general. So C# is an easier language, a far easier language to implement. There's been much more effort on VB, and VB has more features.
Sure.
A lot more features. It's
Really?
just been around for a long time, and
Yeah.
it's got a lot more features. So yeah, that's been a challenge. I mean, when you think about, well, hey, we're almost there. It's like, oh no, we still have XML literals and things like that. I mean, VB's got a lot of features.
Eric Meyer, man.
Eric Meyer.
Oh, Eric.
That guy. He's made my life hard.
Dude. XML literals, man.
Yeah.
But he also gave you some core ideas for Roslyn as
Yep.
well.
Yep.
with the functional stuff. I know Anders got kind of brainwashed a little bit into the functional world by Eric always chirping in his ear. But I think that's great, because I think it's a great cross-pollination between very smart people.
Yeah, I agree.
In terms of, I don't want to talk about ship dates or stuff like that, but I mean, I want to kind of step back a little bit. Did you learn more about the language itself? And did you find any bugs or questionable designs in the language when you're re-implementing a compiler of said language from scratch?
Absolutely.
Okay.
Absolutely. We found there's a lot of kind of big names on the Roslyn project. I remember I was having lunch with Eric Lippert, to drop one of us, right? And he was describing to me a typo in the C# compiler that meant, and I'm trying to remember how this all worked, but it meant that conversions from interfaces actually happened differently from the spec because of a typo. And so there's a giant comment now on the Roslyn compiler about why it's implemented this way, because we don't want to break people, because clearly somebody did this. Okay. And that's, it's always surprising. We'll find somebody will go through and implement something to spec, and then QA will kind of swarm in on it on the new feature and then say, no. So the actual native compiler did this, even though the spec says this. And so there's been a lot of that. It's actually been...
but how do you recover from that? Because you have to be backwards compatible.
Absolutely.
Do you just pass the bug along?
No, we need to make a decision about it. We found, and it kind of is on a case-by-case basis, right? Some of them, if we changed it, would be a breaking change. Some of them would be a breaking change, but nobody did this. Clearly, nobody did this, and it's an artifact of the way the native compiler was implemented that this is even possible to do. Okay. A good example of that is we had a bug really early on that we found that when I did an import statement in VB, which is like a using directive in C#, if I do an import statement, VB has those little type suffixes you can put at the end of the, to me, like, dollar means a string and percent means an integer and all of that.
Right.
Yeah, you can put those at the ends of the identifiers in a namespace in an import statement. So I could say import system dollar dot collections percent, and we're like, should we keep that? Somebody might have code that might be broken if they had that, and maybe it was a copy paste thing. We decided instead, no, that's an example of something where we didn't. An example of something where we did was where we found that the spec says that we don't do implicit conversions between like int pointer and uint pointer and that sort of thing in C#, and we absolutely do. And so that's an example. So no, we have to go do that. We absolutely have to go do that, or we'll break somebody.
Sure. Well, that's good.
That's but everything's taken very seriously.
Of course.
Go through some review and take a look and say what's the right thing to do here.
Absolutely.
Yeah.
So the question that's in from RD3D. What is the next big compiler technology after Roslyn?
You guys think future. Roslyn's in the future, and you're thinking, what's the future beyond that?
Yeah, exactly.
I have no idea, honestly. Right now, it's really about let's get Roslyn out there and see where it's going to be. I do think that there are some thoughts we have for V2, but they're not really cohesive enough to share right now.
That's fine, no worries.
We do have some things that we'd like to do, some scenarios we'd like to go after. But right now, Roslyn V1, let's get this done. I'm sorry, I hate to answer it that way, but we're just trying to be laser focused on this one. Yeah.
But in terms of it, I think maybe looking way out into the future, or not even that far into the future, in the cloud you get 1 million cores someday, and literally you will be able to do that.
Yeah.
100,000, let's say. A healthy application might be 100 kilobytes, right? Maybe a meg if you have all your resources embedded and stuff. I mean, we're not talking about an operating system, but a pretty good size app. It doesn't take that long to upload a meg to some service that just blasts it out. But now I have to pay for that compute. I'm not saying that it's going to be free.
Absolutely.
But I mean, there's some interesting ideas, and let's see where this cloud computing thing could take us.
There's the cloud computing thing. I mean, if you look at what F#'s done with type providers there to be able to look at data.
Good point.
I don't know if that will make its way into C# or VB, and I'm saying that now, I don't know if that will make its way into C# or VB at any point, but that is, that's a really interesting feature for dealing with things that are with so much data. The schema is so huge that you couldn't possibly code gen it. I did a demo yesterday for my F# talk where I was just using IntelliSense to dot into Freebase his data schema, which is so enormous because it's like Wikipedia with a schema that to code gen it would be ridiculous.
Yeah.
And so you can imagine something like that where I'm able to discover my service, able to discover my data, discover the compute power that's available to me.
Yeah.
And there might be other stuff beyond that that's not in here, but that's the sort of thing I'm I'm seeing
Sure.
as potential stuff coming in the future.
Now, one of the things we talk about a lot these days is GPU. And I had a good conversation with Kate Gregory and Steve Teixeira this morning about
C++ guys, yeah.
Yeah, of course, man. It was Going Native Live,
right.
The show that I do on C9. Used to be once a month. Sorry to everybody that's got kind of slacking a little bit, but general purpose in quotes, right? I mean, because you have to have a very specific problem you're trying to solve to target the GPU because of its constraints and what it expects. I mean, you're talking about data parallelization, data parallel computation. Could you use the GPU from your world to speed up compute? Not in your
Possibly.
Potentially.
It would be a larger endeavor, right? It would either be, making sure that we, because C#, it's very dependent on its garbage collected, environment. And so to do that on a GPU would be a big effort, I think. It's something that's interesting. It's something that I think there are people thinking about and looking at, but it's not something that I don't know if we'll get to very soon.
Rock and roll. So let's get to some good questions. So, Ad Hood, thanks for asking so many questions today. Will any new language feature be added to native compiler after async? If not, will Roslyn delay the development of new features?
That's a great question.
Yep.
Yeah, that's a really great question. There are kind of some new language features that are coming in Roslyn, mostly around this notion of the scripting piece that's part of Roslyn. So if you've downloaded the CTP, you've played with the interactive window in C#.
Yep.
The interactive window allows you to put statements at the top level outside of your method bodies and do all sorts of interesting things there. So while Roslyn may slow the development of some traditional language features, there are definitely language features coming in the scripting space so that you can do C# and Visual Basic scripting. So yes, in the sense that we won't go after, when in the product where Roslyn ships, will not say, let's go do a dozen language features, because we'll probably be focused on making sure that Roslyn integrates well and that customer code is not broken and everybody's really, really happy with Roslyn. So in that sense, it may slow some development, but Roslyn does have a couple of language features in its back pocket that are coming with it, so in the scripting area. So
excellent. And I think with the next version that you guys are shipping in Visual Studio 2012, I think the async await model very, very helpful, especially with people in the WinRT world, which is aggressively async.
Yeah.
You get a very simplified way of putting your mind around asynchronous programming.
Absolutely.
By just simply doing async await. I mean, it's Anders loves simplicity, and I think that design is beautiful. Scales up to a certain level, then you can mix it with RX when you need to get crazy, which will add some conceptual overhead. And of course, C++, we're still waiting, but we have PPL, and we have some async in the standard library, in the C++ 11 standard library.
Right.
So, all languages are starting to modernize to that world.
Yeah.
And it'll be nice to see. Could you do something with Roslyn where you would be able to parallelize loops? So in other words, could I analyze my code to decide whether or not this could be auto vectorization doesn't make sense because you guys don't target hardware, you target a virtual machine.
It depends on how you want to do it.
Okay.
If you wanted to introduce or a factoring that would detect whether a loop could be parallelized using Roslyn APIs for the analysis and then implement the refactoring, absolutely.
Okay.
If you wanted to weave into the IL writing process and rewrite that's another story.
Yeah.
That's a different piece.
That's a different piece.
You could still do the analysis with Roslyn on the source level, detect that, yes, that loop could be parallelized, and then do your own bit to rewrite the IL at the end. You could certainly do that.
Okay.
Yeah, you could do that work.
Excellent. All right, so Hood has another question. Mono has an optimizing AOT compiler. Will Microsoft do something like that? Can you tell us what an optimizing AOT compiler is for people out there?
I actually don't know what an optimizing what the AOT stands for.
Okay.
But probably not at this point.
Okay.
Right? It's more, right now it's like, let's duplicate the existing compiler functionality. So going after new scenarios, new types of compilers, and new types of optimizations isn't what we're doing with Roslyn. Maybe in the future, that's possible, but not right now.
Sure. And I'm sure the Mono guys are already playing around with their own version of Roslyn.
Yeah.
I'm not sure what they would call it. What is why?
There's got to be a monkey name that somehow links in with an R and
Absolutely, something like that. But those guys are sharp. They're sharp guys. They're no longer Mono. They are now
Xamarin. Yeah.
Xamarin. So they got some really good engineers, developers over there. Too bad they don't come and work for Microsoft, but better that they stay out and keep us.
Their monodroid, monotouch technologies are pretty cool. So
excellent, man. So tweet questions to #CH9 Live. We're talking Roslyn, and we have somebody here, Dustin Campbell, that's working on the project as a developer. He can probably answer most, if not all, of your questions. So more. So one of the things I think is interesting in this day and age is sort of writing code in one language and compiling it into another.
Okay.
So I write C#, but I want the output to be JavaScript.
Okay.
Because maybe I'm writing a Windows 8 app which doesn't support HTML and C#. So I'm doing my C# stuff, and trust me, I've done a lot. Personally, I would not do this. Somebody whose name I won't mention is very upset that he can't do this, but it is possible to do.
Yep.
It just is going to require a fair amount of work. Can Roslyn do that sort of transformation? Could I say, highlight this code, but give me something else?
Yeah.
Of course.
Yeah. Simply because you have a representation of everything about that code.
Beautiful.
You could take it and rewrite it to something else. One of the early samples we did, and I know Anders showed it at Build, but it was the C# to Visual Basic and vice versa. We have just guys that you can copy and paste C# code, copy it, paste it as VB, and do that sort of thing. Which is that one's a little more contrived than some of the scenarios you described, right? So it's kind of funny, but it's really nice for MSDN guys to build their samples.
Yes,
but
totally.
There's some nice scenarios there, but yeah, you can certainly do that with Roslyn. You have everything available to you about, if I see an invocation in my code, what method does this actually bind to? Well, you can find that out.
And one area that we don't talk about that much in terms of Roslyn is developer education.
Okay.
Because a lot of developers, a lot of .NET developers, and a lot of developers in general may not understand what's going on underneath and what their code actually looks like before it gets, transferred into what they absolutely will never be able to understand, which is a bag of machine junk.
Yeah.
So the question is for you, do you guys think about that on your team? Like, wow, this would be a good way for people who are curious about programming language design to be able to say, hey, this chunk of code I just wrote looks like this at some intermediate state. And I'm not talking about IL, I'm talking about abstract syntax trees and stuff like that. Stuff we generally don't see in the IDE. And you could actually build, hey, by the way, this code is going to transmute or transform into this. And you can kind of go through and understand what it means and map it out. It might be a little too dramatic.
Yeah, that's an interesting idea. So actually in Roslyn, from an API perspective, we actually don't expose what's traditionally known as an abstract syntax tree.
Oh, okay.
So we have a syntax tree, which is the parse tree. We call it a syntax tree. And then we provide an API that you can ask questions. So we don't actually expose kind of our bound tree. We kind of keep that hidden under wraps.
Okay.
Just because, that's the sort of thing that changes dramatically when you add language features. So that has a lot of opportunities to break people. And it's another tree to have to ratify and build as an API and do all of the work. Right? So right now it's a binding API. So it'd be harder to show an abstract syntax tree. You could build something like that. You could build a syntax tree. You could take the binding API and you could ask questions of all the nodes in there, and then you could build that up and you could show it off. That's not something I've thought about though as a scenario. That's pretty interesting.
Yeah, I mean, I just think because it's interesting what really goes on. Yeah. And what programming languages really are.
I've learned all sorts of things about that sort of thing as well. Right, being able to say when I have a long, like a field that's a long, and it's assigned immediately like with the value 42. Right, when I bind that 42. That's not a long, right? That's an integer. That's an int32, and it converts to a long. And learning those kinds of things and how my code actually flows, how the types flow through it, it's actually very, very interesting.
Absolutely.
So from an IDE perspective, and I'm kind of the IDE guy, I'm thinking about like, well, that would be a really interesting feature, right? I can think of it being very useful in something like F#, where maybe I'm using a lot of type inference, and I want to see how my types flow through here. Often when you go to like older functional programmers, they don't they don't use the debugger and set breakpoints to debug, an application. They say, well, how did my types flow through here? Oh, they flowed all right? Well, then my program's correct.
Nice.
Right? And so you can imagine building some tooling around that sort of thing. That's a pretty cool idea.
Absolutely.
Yeah.
I think it would be extraordinarily useful. So we're winding down here. We have about 1 minute left. If that, it's time to wrap up time. Hey, it was really great to talk to you.
Charles, it was fun.
We're going to have to get you back on Channel 9.
Absolutely.
We'll check in and see when you guys have more to say.
Yeah.
Maybe you make some breakthroughs and, you have a ship date. Stuff like that.
That's what everybody wants to know.
But it's a super hard problem
Yeah.
to take a compiler, tear it down, and build it back up again.
Yeah.
So nice work, man.
Thanks, Charles.